All right, so these are the results of a survey of 62 high school students that are given in the table and asked about their favorite sport and their gender. So, first one, what's the probability that any student here selected is a girl? Well, we probably want the totals first. So I think across the side, did anybody already count them? 32 and 30, right? Well, go ahead, count it up. I said it's out of 62, so if one's 32, the other's 30. Let's look at others. 2, 4, 6, 24, and then 26. So what's the probability that any student selected from the study is a girl? Anyone? Yeah, 32 out of 62. You said 57. I'm going to trust you on that. What's the probability any student selected as a fan of football? 24 out of 62. You have 51. Great. What's the probability, and this is key here. It wasn't 57, it was 51?
Yeah, I did 57 in my head.
Okay, well, for the sake of being accurate, the first one was 51. What is the probability that any student that's selected is a girl who likes basketball? Exactly. 18 out of total 62. Girls, basketball, total. You said that's about what percent? Okay. Now we start getting more specific. What is the probability that a student from this survey is a soccer, let's say soccer fan, is a soccer, given that the student was a girl? So remember, this is a conditional probability, which is both over what was given. So soccer and girl intersect. How many at the intersection of soccer and girl? 3, given 32. It says given. In this case, it says given that the student was a girl. Here's 32 girls. 3 out of 32. Question? I'm pretty sure people are still. Remember when I'm talking about formal independence? If I'm giving you a table with these, you have to be very specific. Remember, probability of A. If they're going to be mathematically independent, the probability of A is equal to the probability of A given B. Or in this case, by the way, actually, let's read E for a second. Call me out on my error. Are being a high school girl and being a cat lover independent? So, O'Connell, why are you talking about cats? I wasn't thinking about my cats, but I based most of this review off of your test. And, well, you can kind of guess what's part of the table in the test. So, let's change this from cat to high school girl, and we already talked about soccer, right? So let's talk about. Well, I didn't give you any probabilities on cats.
A soccer lover.
Or we could just change the word cat to soccer, or if you would prefer, if you personally want to change your table to cat, it shouldn't make a difference. Anyways, this is your formula that you're going to use for independence. So if I said the probability of being a soccer fan was equal to the probability of being a soccer fan given that they're a girl. Again, cat is not supposed to be in this problem. All right, here's a hint. Tomorrow's test, cat is part of the problem. If you don't understand this formula, no, you won't. Probability of being a soccer fan is what? 4 out of 62. That's 064? Okay. And the probability of being a soccer fan, given that you're a girl, was close. It's actually the problem we just solved above. Just look above. What's the probability? Look at D. What's the probability that a student in this survey is a soccer fan, given that they're a girl? Well, we already found that. 0.09. Are they equal? No. So they're not independent. Being a fan of soccer somewhat depends on whether you're male or female. Bless you. Let's try and finish this up. 15. An AP Stats study of 23 randomly selected students found that 43% of students approve of the Lady Gaga's Super Bowl performance. The should not be in there. Can a normal model be used? Why or why not? What do you need for the normal model? 10 successes, 10 failures. Well, 10 successes would be NP. What's N? And P? All right. What's 23 times 0.43? Ooh, 9.89. Do we round it?
Nope. Down.
Hater. Oh, this is not, I made it up. I don't know that 43% actually enjoyed that performance. I thought it was pretty cool. Yeah, actually, my guess is that more than 43% of us like that performance.
I don't think
Are you
What
Are you the majority?
Anyways,
Yes.
before this time expires, 9.89. I'm going to round up to 10. Basically, you could say yes if you round 9.89 to 10. Otherwise, you're totally fair saying no, you can't, because 9.89 is less than 10. That's fine. Either way.
So do you always use 10 successes and 10 failures?
Yes, and so obviously the N for 10 failures we didn't check yet, but N is still 23. But if the probability of success is 43, that means probability of failure is even higher. So you know that if 43% was 9.89, you pretty much know that percent chance of failure, or 0.57, that's going to be higher than the 10. So that's fine. So if not, how large would the sample have to be? Well, that was just when we did N times P has to be greater than or equal to 10. Or how large would the sample have to be? Well, that means keep N as a variable and just do 10 divided by 0.43. And it's still 23.25. So that one would still even round down, but if you want to say 24, that would be fine. I chose a random number. I didn't necessarily test this to make sure that you knew, but 10 successes, 10 failures. Well, I use numbers off the top of my head, but we've kind of proven that humans aren't very good at being random. So, any questions before I stop the video?
No.
All right, class of 2017, shout out before we stop this. Say hey.
Hello.
Hola, como estas?
Bien, y tú?